All right, I'm going to show you, this is the ambiguous case parts 2, and I'm going to show you how to solve a two-solution problem. But first off, I'm going to show you this problem. And we have angle side side. So we go, is there 0, 1, 2 solutions? So remember I compare the opposite side 4. This is the side that's next to the angle. I multiply that with my calculator, 12 times sine of 40. So if I punch in, let me do that real quick. 12 times sine of 40, I get 7.7. So since that side's bigger, this is impossible. This 4, if I drew it to scale, would be like hanging in the air. We couldn't have a triangle. So that would be a no solution problem. And there's nothing to do. You say there's no solution, you move to the next problem. So let's move this to a 9. So if that was a 9, then it's actually greater than 7.7. So then that means there's 2 solutions. If that was exactly that same, whatever ugly decimal, 7.7, then there'd be exactly 1 solution. So there's actually 2 solutions. So here's how you find them. Because this side is so long, it's 9, it could go this way or this way. So the other picture, instead of going wide, it's coming back. So instead of going this way, it would come back. So this is still 40, this is 12, and this is still 9. It's just your 9 come this way. So I'll put it in the same picture here. So those are your scenarios. So the 9 could go this way, it could go this way. So that's why there's 2 solutions. So we got to find both solutions. So if we're going to label these with letters, as I said, I'm showing you without letters, so you show it doesn't really matter. But if they like to call this one A, and we like to call this one B, and this one we'll call B. This one actually, B, and this one is C. Yeah. So that's how we do it. So I'm gonna do the same with here. So since they're different, I'm gonna call this one B1 or B2. Wow. 1. All right. Get my mind straight here. So this one we'll call B1C1, and this one we'll call B2C2. So how do we go about doing it? Well, we do the law of sines. So I got this pair, and I'm missing this, so I need to find the first angle B. So sine of B over 12, sine of 40 over 9. All right, so I need to solve that. So I would multiply this 12 up here, and then do it. I've already done the work, and I get B1 to be 59 degrees. Now, it was actually 58.9 something, 0.95 or something, so rounded up. So I didn't mean that to happen, but hey, we got 59 degrees. So we know which of these 2 angles that we find. We said we're finding B1. If you were to do law of sines here, you get the same answer. You're like, well, they're the same answer. Well, remember, because sine is positive in quadrant 1 and 2, whenever you do this arc sine, it will always give you the quadrant 1 answer. So your calculator is actually programmed to always give you an acute angle with law of sines. So what happens is, this is actually 59 degrees. You can see that's the acute angle. This one looks obtuse. So how do you find the obtuse? Well, let's go to this picture. If you find this is 59, well, look at this little triangle. It means nothing to this problem, but you see the 9 and 9, we have an isosceles triangle. Remember, if 2 sides are equal, the angles opposite are equal. So actually this would be 59. So this other angle B is a linear pair. Remember, on a line they add up to 180. So I actually can find the other angle quickly as I subtract 180 minus this, and I get 121. And there's your 180. So then this angle, B2, is 121 degrees. That's how you find, that's it, to find the second solution. That's the key to everything. You do a law of sines once, you'll get an angle for that B. The other angle B is 180 minus that answer. I'm showing you why that's always going to be true, no matter what the picture is. These always are going to be a linear pair, and so they have to 180. So now that we know 2 angles of a triangle, we automatically know the third. In this picture, these 2 add up to 99, so what's left? 81 degrees. So now you got angle C1, 81 degrees. So then this angle though, this angle C2, Well, that's 40 and 121, so that's 161. There's only 19 degrees left, and that's angle C2. So what do we have to find? They gave us side A and angle A, and they gave us side B. So now we have two angle Bs, two angle Cs, and we would list them separately. And then we can call this side C1, and this one side C2. So I do law of sines. Side C1 goes with sine of 81. Remember, it's side to the angle or angle to the side, either order. See, and then the one they gave us was the 9 and 40. I'd use that. All right, I've done that work. C1 turned to be 13.8. Just multiply by sine of 81, punch in your calculator, and you go, oh, 13.8. So now we know how long this side is. Now, just think about it. 13.8 is bigger than 12 or 9 because it's across the biggest angle. It should be the biggest side, all right? Well, this guy's tiny, so he should be less than 12 and 9 just because he's the smallest angle. So C2 over sine of 19 equals, again, the 9 over sine of 40. I punched this one in my calculator also. I got C2 to be 4.6. As you can see, it's pretty small. It should be the small side of the triangle because it's the smallest angle. So that's how you find them. So what you could do when you're listing the missing information is, hey, I'm missing angle B1, I'm missing angle C1, and I'm missing side C. Those are the three things missing. And then we would also list out, hey, I'm missing angle B2, angle C2, and side C2. So remember, angle B1 was 59 degrees. And then I immediately know that was 121. I could find B1 and go, oh, that's 59, so that's 180 minus it. And then I just solve them as two different, it's now two easy problems in one. Angle C1 is what's left, which was 81 degrees. 19 degrees for that guy. And then I do the two law of sines to find the last C's, 13.8 and 4.6. All right? And that's how you solve a two-solution problem. So the key is this picture right here helps you out with that. All right, now, just to do a little review of area, remember I like the corner. So I think I'll highlight this corner right here. And I'll just do this corner for both. So this is a bigger triangle, this one. So the area is 1/2. Remember, side times side, 12 times 9 times sine of 81. So if we had to find the area of each triangle, so we can call this one area of triangle 1. And I punched that in my calculator, and I did it earlier, and I got 53.3. So now I got 53.3. Area for, I guess that's 1. Number 2, it's 1/2, 12 times 9, sine of 19. So you can see how it's going to be smaller. Sine of 81, remember sine of 90 is 1. Sine grows in the graphs from 0 to 90. So sine of 19 is pretty early. It's not a very big number, so you'll see you get a smaller answer. I did it, and I got 17.6. So it's a smaller triangle, should have smaller area, okay? So that's how you do two solutions on ambiguous case. It's just when we have the ASS, the information is not clear. It's ambiguous. All right, that's all that's referring to, okay?